In the deepest depths of the inner solar system, a tiny world endures a relentless, unyielding assault. It is an anvil, forever struck by the hammer of the sun. It is a world of absolute extremes, of blinding light and eternal darkness, of scorching heat and freezing cold.
This is Mercury.
The smallest, fastest, and innermost planet of our solar system. For centuries, it was dismissed as a dead, boring rock, a mere cinder left over from the birth of the solar system, too close to the sun to hold any true mysteries. But as we have dared to look closer, to venture into the inferno, Mercury has proven us wrong at every turn. It is not a simple cinder. It is a dynamic, bizarre, and deeply mysterious world that actively defies our understanding of how planets are born and how they evolve. Mercury is a planet defined by its relationship with the star it orbits. It sits at an average distance of just 36 million miles from the Sun, barely a third of the distance between the Earth and the Sun. Because it is so close, the Sun's gravity grips it tightly, whipping it around in its orbit at a staggering 29 miles per second. A single year on Mercury, one complete journey around the Sun, takes just 88 Earth days. But its days are a different story entirely. Mercury rotates incredibly slowly on its axis. Furthermore, it is locked in a strange gravitational dance called a 3-to-2 spin-orbit resonance. For every 2 orbits it makes around the Sun, it rotates exactly 3 times. The result of this celestial clockwork is a day-night cycle unlike anything else in the solar system. If you were standing on the surface, you would see the Sun rise, grow massive in the sky, stop, reverse its course, stop again, and then finally set. From a single sunrise to the next, a staggering 176 Earth days would pass. This excruciatingly long day, combined with the almost total lack of an atmosphere to distribute heat, creates the most extreme temperature fluctuations in the solar system. At high noon on the equator, the surface temperature reaches a staggering 800 degrees Fahrenheit, or 430 degrees Celsius, hot enough to melt lead. But cross the terminator line into the night side, and the temperature plummets to minus 290 degrees Fahrenheit, or minus 180 degrees Celsius. It is a world of fire and ice, existing on the very edge of the abyss. Because of its proximity to the Sun, Mercury has always been an elusive target for humanity. It never ventures far from the blinding glare of our star. It can only be seen with the naked eye briefly, low on the horizon, just before sunrise or just after sunset. A fleeting spark in the twilight. The ancient Sumerians recorded it over 5,000 years ago. The ancient Greeks initially thought it was 2 separate stars, Apollo in the morning and Hermes in the evening, but eventually they realized it was a single wanderer, moving faster than any other light in the sky. They named it after the fleet-footed messenger of the gods, Mercury. Even as the telescope was invented, Mercury guarded its secrets. Early astronomers strained their eyes, battling the blurring effects of Earth's atmosphere at the horizon, trying to map its surface. They drew maps of shifting, ghostly features. For decades, scientists believed Mercury was tidally locked to the Sun, like our Moon is to the Earth, keeping one face eternally roasting in the daylight and the other eternally freezing in the dark. It wasn't until 1965, using powerful radar beams bounced off the planet from the Arecibo Observatory in Puerto Rico that scientists finally proved Mercury rotated. The long-held myth of the dark side of Mercury was shattered. But to truly understand this enigmatic world, we couldn't just look at it from afar. We had to go there. In November 1973, NASA launched Mariner 10. Sending a spacecraft to Mercury is incredibly difficult. It requires bleeding off the enormous orbital velocity of the Earth to allow the spacecraft to fall inward toward the Sun. To accomplish this, Mariner 10 became the first spacecraft to use a gravity assist, using the gravitational pull of Venus to slingshot itself toward its target. In 1974 and 1975, Mariner 10 flew past Mercury 3 times. The images it beamed back were a revelation. At first glance, it looked just like the Moon, a heavily battered world scarred by billions of years of asteroid impacts. But geologists quickly noticed subtle differences. The craters were closer together, and between them lay smooth, rolling plains. The gravity of Mercury, twice as strong as the Moon's, meant that the debris ejected from impacts fell back to the surface closer to the crater, creating different geological patterns. But the biggest surprise wasn't on the surface. It was invisible. Mariner 10 detected a magnetic field. For planetary scientists, this was a shock. Magnetic fields on terrestrial planets are generated by a dynamo, churning liquid metal deep in a planet's core. But Mercury is so small that its interior should have cooled and solidified billions of years ago. A dead, solid planet cannot generate a magnetic field. Yet, there it was. Mariner 10 raised more questions than it answered. Because of its orbital mechanics, every time the spacecraft flew by, Mercury was lit by the Sun in exactly the same way. Mariner 10 was only able to map 45% of the planet's surface. For the next 30 years, the remaining 55% of Mercury remained a blank spot on the map of our solar system, an unexplored frontier. It took over 3 decades to return. This time, the goal wasn't just to fly by, the goal was to stay. Launched in 2004, the Messenger spacecraft, short for Mercury Surface, Space Environment, Geochemistry, and Ranging, embarked on a phenomenally complex journey. To safely enter orbit around Mercury, it had to endure a grueling 7-year flight, making 1 flyby of Earth, 2 of Venus, and 3 of Mercury itself, slowly matching the planet's speed. Finally, in 2011, Messenger fired its thrusters and successfully entered orbit. The veil was finally lifted. Messenger transformed Mercury from a grey, heavily cratered ball into a complex, fascinating world. It mapped the entire planet in incredible detail, and what it found rewrote the textbooks. Perhaps the most shocking discovery occurred at the planet's poles. Despite being a world baked by the Sun, Mercury's axis has almost no tilt. This means that inside deep craters near the North and South poles, the Sun never rises. In these regions of eternal shadow, temperatures hover near absolute zero. Messenger directed its instruments into the darkness and found the impossible: water. Billions of tons of water ice, hidden in the darkest, coldest corners of the hottest planet in the inner solar system, likely delivered by ancient comet impacts. But that wasn't the only surprise. Messenger discovered strange, bright, irregular depressions scattered across the surface, a feature completely unique to Mercury. Scientists called them hollows. These hollows suggest that Mercury's crust is rich in volatile elements, substances like sulfur, potassium, and sodium, which boil away into space when exposed to the brutal heat of the sun. This was a profound paradox. If Mercury formed close to the sun, the intense heat of the early solar nebula should have baked these volatile elements away before the planet even finished forming. Their presence suggests that Mercury may have formed further out in the solar system and migrated inward over billions of years, or that our models of the early solar system are fundamentally flawed. In 2015, out of fuel and succumbing to the relentless pull of gravity, the Messenger spacecraft crashed into the surface of the world it had studied so intimately, becoming a permanent part of Mercury. But our quest to understand the iron planet is far from over. Currently, a new explorer is making the perilous journey to the innermost realm. Bepi Colombo, a joint mission by the European Space Agency and the Japanese Aerospace Exploration Agency, is the most advanced spacecraft ever sent to Mercury. Arriving in orbit in late 2025, Bepi Colombo will do something unprecedented. It will split into two separate orbiters. One, the planetary orbiter, will map the planet in unprecedented multi-wavelength detail. The other, the magnetospheric orbiter, will fly higher, plunging through Mercury's strange, offset magnetic field to understand exactly how a planet this small can generate a magnetic dynamo. Together, they will map the distribution of water ice, probe the deep interior, and search for the definitive answer to how Mercury formed and why it is so rich in heavy metals and volatile chemicals. For most of human history, Mercury was a footnote, a difficult-to-see dot of light, dismissed as a barren, baked rock. But exploration is the engine of astonishment. By daring to fly into the fire, we have discovered a world of impossible contradictions, a world with a massive iron heart that shouldn't exist, a world of scorching heat that harbors ancient ice, a world that is actively shrinking and shivering under the relentless gaze of the sun. Mercury reminds us that the universe is not simple. It does not easily conform to our theories or our expectations. Every rock, every crater, every shrinking cliff on this tiny world holds a piece of the puzzle of how our entire solar system, and perhaps solar systems around other stars, came to be. It is no longer just a cinder. It is a masterpiece of planetary evolution. It is Mercury, the iron enigma, waiting in the blinding light for its secrets to be discovered.